Right. Registers are going round. Last week the registers didn't get back to me. Nobody on the balcony was here last week because nobody on the balcony could be hacked to give me the register back, and it wasn't there on the balcony when I went to look. If it doesn't come back, anybody who was on the balcony last week isn't here. If this happens again, I'm not going to give a register up to the balcony anyway. You can come down here and sign it downstairs, because as I've said several times, there are spaces down here. You don't have to be on the balcony. That goes that way. That can go that way. And whoever did take the register last week, please give it back ASAP. Check your notes if you were on the balcony in case you took it with whatever papers you were messing around with at the time. That goes that way. That goes that way. So everybody on the balcony, everybody in each section is responsible for making sure that register gets back to me. I hope you're okay.
It was an event the weekend, so we put the console back in this morning. Nothing's gone awry.
So it doesn't need plugging into the...
No. It's all right, it's just that you need the two visualisers, don't you?
Yeah, so I want to switch from one to the other, basically.
Not sure what's happening there, it's all a bit red.
That's a big problem.
There was another event Wednesday and somebody walked off with the power supply for this. We even need to do teaching or events.
Well, we're just setting up the other dot cam for me. There's a handout here. So normally you would be doing a diagnostic test in the labs. Normally you'd be doing a diagnostic test in the labs on loops this week, but because we're doing the midterm test, you won't have the chance to do it, but given it's relevant to the test because it's got things like dry run examples about for loops that we're doing, I'm giving it out now, so if that's something you want to have a go at some point before tomorrow, feel free. And I won't give them out now because hopefully, when we've got this sorted out, I'll give the feedback sheets out. So pass these backwards. So take one and pass them backwards. So feedback sheets are here as well. I'll pass those out in the break. It'll be okay. If I use that as the first one, so if I do that to Q review, so that's
HDMI now.
So that goes to Q review, and then .cam goes to project 2, and I'll start
Some more dodgy one. Actually, I'll put looking in here.
Thanks. Right, and the midterm test is in your lab tomorrow. If you miss it, you could end up failing the coursework. If you do miss it, you need a doctor's note or some other documentary evidence of why you've missed it. Okay, so what I'm going to do first half of today is something that's sort of preparation for the midterm test rather than start straight away on a new topic, what I'm going to do is do a review of the stuff we've done so far by going through an example program. So let me get the slides. I'll do this off of slides. So what we've done so far is a bunch of things about commands, expressions, assignment, and then last week loops, and that's, and records, and that's all the stuff that potentially is on the midterm test. And you are going to be required to write a program. So what I thought I'd do is go through a program and show you the way I would go about attacking this. If there's time, I'll do this twice in two different styles, two different ways of doing the same program. But this is the sort of thing you're going to have to do actually in the midterm test itself. And part of this is as a result of some of the questions on the forum, so I hope this will help to give you an idea at least how I would go about writing programs. So this is basically a variation of a program and exercise we kind of looked at last week. Suppose you've got a program that's basically printing messages about pets. This time what I wanted to do is just decide whether pets are exotic or not and count them. Okay? Last time we looked at this, it was just an if statement. Now I'm saying, so it did it just once. Now I'm saying, write a program that does this 50 times over. So what I want is essentially to do a survey of maybe everybody in the room of their pet, and they're all going to come up to my program and sort of answer the question about what pets they've got, and then it's going to count how many are exotic, where exotic are snakes and monkeys. So maybe the program will know about lots of different kinds of exotic pets and lots of non-exotic pets. For now, we'll be satisfied it just knows about snakes, donkeys, cats and dogs. Sorry, snakes, monkeys, cats and dogs. Okay? So, given a program to write like that, how would I go about writing the program? So I'm going to put my life in my hands now because I'm actually going to attempt to write this on the spot. Oops, that's like gone on. And I am undoubtedly going to make mistakes as I go along, presumably similar sorts of mistakes as you make. You can point out ones I do. I'm going to try and do a commentary as I go along, explaining what I'm thinking as I write the program. So the first thing here is just to think about what the steps are, and essentially there are two sort of steps to this. It's basically one step is to 50 times over ask people about what their pets are, and then a second step is print out some count, some message about it. So how would I go about writing a program like this? I would actually do it, essentially plan it as I go along. So rather than writing pseudocode, which you might have come across in school, or sort of semi-English versions, partly this is what methods can be used for, sort of what's called top-down programming. So the first thing is, it's going to be a class. Oops, I can't see where am I at the top. If I go off the top, you better shout, because I can't completely see what's happening over there. So it's going to be something, a class pet count, and what I do to start off with is write the open and close curly brackets somewhere down the bottom of the page. I immediately write my close curly bracket just because that stops me forgetting about it. At the top I'm going to want to comment, and I'll just put a short one for now. See if I can adjust it so that where the top here is. Oh, that works better. I might also at this point remember, oh, I want to import a library. I'm probably going to use the scanner library, so I'll do import Java dot util dot star, just so I don't forget that. And then we're going to have a main method. So let's start by writing the main method. So hopefully you could just do that straight off. Public static void main string square brackets A, or something along those lines by now. Again, I've put a curly bracket, so I'll write in another curly bracket a bit lower down, somewhere where it will go, just to make sure I don't forget to close it. And then going back to what I said, so what is this program? It's in sort of two stages. So the first stage is something along the lines of ask about pets. And then the second job I've got to do is print how many were exotic. So what I've just done is essentially turned that into two procedure calls. So just looking at the question, there's two separate sections. I'm not going to worry at this point about the details of the sections. What I'm doing is just sort of creating methods that do each, and I can worry about the details of how they do that later. But what this program has to do is ask about 50 pets and then print some message about how many there were. Now this is the point where people have been struggling a little bit. How do I pass information from one to the other? So ask about pets is going to keep some kind of count of how many exotic pets there were, and yet print how many exotic actually needs that information. It needs the same variable, you think. Well, no, it doesn't need the same variable, it needs the same value. So what I do is I deal with all of that here in the methods that's calling them. So ask about pets, its job is actually to return back a count of how many exotic pets there were. So it's going to be a function that returns an integer, the count of how many of those 50 were exotic. So I'm going to store that in a variable called count. And that variable is going to be declared here. It's got to be, because I'm using it in this method, so I'm going to declare it local to this method. So I declare it, this method does that count and returns the count, and then this method needs that value. It can only print the count if you tell it what the number actually is, and the number is stored in this variable count. So I need to pass that as an argument. So I need to write that value inside the brackets that acts as the argument. Okay? So what I've done is I've got two methods. I haven't worried about the details yet, but all I know about them is one, its whole job is to come up with how many exotic pets were in the 50 that the people typed in, and the second one's job is, given that piece of information of how many exotic pets there were, it's going to print out a message about them. So this one returns an integer, and this one is given an integer. Okay? So I haven't had to worry about any detail beyond that, but I've got the whole structure. I've planned the program as I've written it. I've used the method calls as the plan. And then, presumably, the third step, maybe I'll work out later, be other things to do, but probably the first step is just to exit. Okay? So, any quick questions about what on earth I've been doing there? Yes? Would you be marked down if you you mean in count gets the value, blah, blah, blah? No, not necessarily. If what you do is end up putting declarations in the middle of a long stretch of code, then that's bad practice. It's better to have the declarations at the top. But if the first thing you're doing is using it straight away, then yeah, that's fine to combine them. But essentially, think about it like a recipe book. Recipes have a list of ingredients at the beginning, and then later on you start to use them. And it's helpful with variables, you do the same thing. You have the list of variables at the beginning so you can see what variables are local. You can easily go back as you're writing a program or reading it and see what actually are the variables called. Okay. So, anything else? Yeah. So if it says just a method, then I'm kind of saying I'm not bothered about you writing the stuff at the top. On the other hand, you can probably do that in less than 30 seconds, so I'm not really saving you an awful lot. But if it just says write methods, essentially I'm just expecting the individual methods. Okay, so having done that, I've now got the job of writing these methods that I've used, and I know what they've got to do. I just don't know at this point how they do them. So I could do print how many exotic for starters, because that's perhaps easier. All the work is actually in Ask About Pets, so if I was running short of time at this point, I would almost certainly go straight to Ask About Pets, because that's probably where I'm going to get most of the marks, because that's where the complicated stuff is. But if I've got loads of time, then just to get me off the ground, I might do print how many exotics. So let's write that now. Public static void, because it's not returning any value. This is a procedure. Its job is just to do some print stuff. Its name is print how many exotic. And what it's given as an argument is a single integer, and it's a count of the exotics. So I'll call it a different name here. It's a different variable, but I could call it the same thing. Whatever was in count when this gets called, when you execute this line, whatever value is in count gets passed and gets stored in exotics. Okay, and what do I want to do here? Well, it's just printing out a message. So I'll call a print method, and thank you. So out of 50 there were okay, so it's just going to call method print. I could write system.out.println there. I think I've got plenty of time, so I've parsed it off as a separate method, and every time I want to print something, I'm just going to use that print method, is the idea, and I'll leave that till later. But what I've already done in writing that is I've shown I can write a procedure call that's passed arguments, and I've shown I can then write the definition of that uses the argument, because exotics is passed there and then it's used there. So I've sort of demonstrated a little bit about what I'm doing, what I'm able to do. But this question is clearly about loops, so most of the marks are probably there for showing I can put a loop into it. So somebody had their hand up? No? Changed their mind? Any other questions? Yeah. So shouldn't exotics be count? I can call it whatever I like. It's a variable. So the value in main is stored in one variable called count. I need to pass the value, not the variable. So going back to boxes, what this program is doing, main, that's me, has got its box, and the count will get stored in there. That's the thing called count. When I call the method print how many events, whatever value is in there, some number, maybe it's 22, has been put in there by the ask about pets method, when it returned, it passed a value and we put it in there. When I call print how many exotics, it immediately creates a new variable, a new box, and that box isn't called count, it's called exotics. And both of those boxes exist at the same time. Main can access this box, and print how many exotics can access this box. Okay? So what happens when we do the call is we look in here, as we're executing this line, print how many exotics count. That says go to count, get a copy of the value, but leave the value there. And then as we go and start executing the code for print how many exotics, the first thing we've done is created this variable exotics, and the first thing we do then is put that value in it. So it's got a copy of count, and it looks exactly like count did. So it's the value that gets passed. It's the value is passed from one to the other, a copy of the value, and then now this is the local variable to this new method, print how many exotic. It can only access this one, it can't access that one. When it finishes, it throws this away, and we go back to main, and main has whatever it had in count. Yeah? Does that explain? I mean, that's a common thing people don't understand. And I could call both of these boxes count, but they would still be two boxes where I'd get a value and copy it from one to the other. So whenever you do a declaration int exotics, int count, that is creating a variable. It's creating a new box that can store a value. Yeah. It varies depending on the situation. If, when you go to a method, quite often you're generalizing, and that method is going to be called in different situations. So in the method that's being called, it almost certainly should be some general version of the name. If what you're doing is sort of what I'm doing here, I'm using it for exactly the same reason, then it makes sense sometimes to have them the same thing. It depends quite a lot on the situation about what's least confusing. So if they are being used for exactly the same thing, then sometimes it makes a lot more sense to call them the same thing, as long as you're not getting confused about them. If the method is a general method, then make what it's called something that makes clear what that method expects. You know, so if what this print method was given a message to print and a count to insert in it, then it's nothing to do with exotics, it's just about print a message about a count. And then it would make a lot more sense to have it called something that didn't mention exotics at all, because elsewhere in the program you might be using it for a different situation, where it was still printing a message with a number. Yeah?
I get what the problem is. I don't get where exotic is being declared.
So where is exotic being declared as a variable? It's being declared exactly just there. That is its declaration. Notice that int exotics looks exactly like int count. So that is the declaration. So it's almost as though that declaration was the first line of this program. And where is it being initialized? It's being initialized when you call the method. So when you jump here, the first thing you do is execute that. But when you do that, you're holding this invisible value that you've jumped with, which is whatever was in the brackets there, and it's initialized with whatever value you jumped with. So you don't need any equal sign in that situation because it's being passed. Yeah, it's back. I haven't brought my baton with me. It's back to the baton. You're passing the baton, which is passing control to the method. And when you pass the baton, you're also taking any value that is declared as being needed, and that value you're taking is initialized into the variable as it's created. So it's part of the call mechanism, part of the process of jumping from one part of the program to the method part of the program. Yeah? Okay, anything else? Right. Okay, so I'm off the ground. I've got two methods written. Notice at this point, I really need to scrub that out because obviously it's the last thing. So I'm going to carry on and put it at the bottom of the next sheet because everything is inside the class. Okay? So at this point, I'm now going to write the next thing. And one of the things you've got to be careful of if you're writing programs like this in this sort of top-down manner is you keep track of which methods you've actually written. So, you know, maybe put a tick next to them or underline them or something. As you invent new things, you've got to remember to go and write the code for them. Okay? So I've done the instructions of how that works. Now I've got to do ask about pets. So what it expects is an integer return, which is whatever the count it's counted is. It's not passed any information. So let's start by writing that. Header public static. So it returns an integer, so it's public static int. And then whatever I called it, ask about pets. And it doesn't take any arguments this time. And again, I've done an open curly bracket, so I stick the closed curly bracket in to remind me that it has to go there, even if I later have to move it about a bit. Okay, so what is this doing? Well, what did we want to do? We've got to do something 50 times over. So the program is saying, ask 50 times for names of pets and then classify them as being exotic or not. So what is this program going to do? It's going to do something 50 times, and that's the job of this method. So the first thing I would do, I might leave a bit of space at the top just in case I need to declare things that I'll work out later. But for int I equals 1, I less than or equal to 50 says do it 50 times, I plus plus. And it's going to do something 50 times. It's once, so this is outside the curly brackets, is going to return some answer, which again is some kind of count. So, actually, I need a variable that's local to here that's keeping track of the same count. So we're creating yet another box for this method to keep track of the counting, and it's going to return it, and it will pass it back so it ends up in that box down there. So I need to declare something up here. And what am I going to do? Well, I don't want to worry about the details right now because that's too much for my little brain to cope with. But basically what's going to happen is we're just going to keep a running total. So we're basically going to say count gets count, i.e. it gets the old value of count from the last time round the loop, plus I'm just going to call another method. So ask for one pet. And again, I'm deferring having to think about the details while I get this little bit right. So I can kind of stare at this small bit of program and try and convince myself it's going to do the right thing. So what it's going to do is declare a variable count. 50 times over, it's going to add to the current count. And I've just seen I've made a mistake. I haven't initialized this. So this is the place where it gets its first value. It needs, before it goes into the loop, to have a value, otherwise I can't add something onto that value the very first time. So I set it to 0, and that's why it's a good idea just to be in the practice of always initializing variables when you declare them, because if you always put a value there out of habit, you're not going to, the one time you really, really need a value there, to forget about it. But that's basically saying, we'll start with a count at 0, we'll add to it every time we find a pet that is exotic, and that will keep a running total. When we leave the loop, we'll have checked 50 different pets, and the count will have kept track of how many of them are actually exotic. So, seems okay so far. Any questions about what that's doing? And what I've done now is I've shown I can use a for loop. I've shown I can write the code that does something 50 times. I haven't actually need to bother about too much of the detail, but I've also shown that I can use an accumulator to keep track of what the count is. And what I haven't had to worry about at this point, because I'm dividing things into methods, is exactly what I'm going to do to work out whether something is exotic or not. I've just deferred it again. I'm planning as I go, basically. Okay? So anybody got any queries about that? About what goes here? Yeah.
Just clarify why
So I is my counter just to keep track of how many times I've asked. So I've got to ask for 50. So I could count from anything. I could count from 0, and then I'd count from 0 up to 49. But that's a bit confusing. We'll see later when we get to arrays, you have to start counting like that. But I want it to count from 1 to 50. So basically, I'm going to do the equivalent of, say, form a queue. Okay, 1. Next person. 2. Next person. 3. Next person. Oh, I'm up to 50. Stop. Everybody else sit down. That's what I's doing. I, in a loop counter, is exactly me counting on my fingers. My hands are I just going up by 1 every time I go around the loop. I++ just means do that. I++ do that. I++ just add 1 to the counter. So if you're counting to do 200 times, it makes sense to count it from 1, because then the number that's the less than or equal to wherever it's gone, it'll be I less than or equal to 50, means I'm counting up to 50. If I counted from 0, then I'd have a different number to the number that I want to count it to. But it's not every time. Second half, when I get to arrays, we'll start seeing actually there are situations where you have to start counting from 0. Why is count different? Because count is not counting from 1. I haven't found any exotic pets yet. So what is the answer before I go into the loop of how many exotic pets I've found? It's 0. I haven't found any. I will only find some and add to that count when somebody has given me a pet and I've checked whether it's exotic or not. So it has to start from 0 because it's telling me the answer so far, and the answer so far is 0. It's only once I've started doing some work that I'll start adding to that. Okay, any other queries? Yeah.
Can you mark this down for including the if statement you're going to do inside ask about pets?
So would I mark you down if you put the if statement in there? Not necessarily. It depends. What I'm not looking for is not things to mark you down for, which you're obviously in the mindset all of thinking, what am I going to lose marks for? I'm marking thinking, what can I give you marks for? Have you shown me that you can do a for loop? Have you shown me that you can call methods? Have you shown me you can call methods that return values? Have you shown me you can call methods that actually take arguments and use them properly? So I'm looking for the positives, not rather than the negative. So there's all sorts of different ways you can write this program. And I'm making this up as I go, and if I did this next week, I'd write a completely different program, where maybe I would put the if statement in there. I'm doing it this way just because I'm in front of 400 odd people. I don't want to make a fool of myself, so I'm breaking it down into small steps because I'm less likely to make a mistake. But then you don't want to make a mistake in the exam either, so maybe it's a good technique anyway. And what I'm trying to get across here is just a good way of writing programs that helps you avoid making mistakes. I'm writing a lot more code this way. Somebody was asking me about this on the forum last night. I'm writing a lot more code this way, but I'm doing it in a way that makes it easier to understand a bit at a time, and also makes it easier for me to write. You can read this program from the top down, and you can stop at any level and think, okay, I've got it now, I understand, I don't really need to worry about the detail. And maybe that's at this point, you don't need any more, and you can see exactly how the program is going to work. Or maybe you want to go a bit deeper in one method and not the other. Whereas if you put it all in one place, it just makes it harder to read. And of course, you want the marker to be able to understand it easily, because that's one of the other things I'm paying attention to. To some extent, it's only a smaller thing at this point, but if I find I can just read your program and immediately understand it, that's a pretty clear program, and I'm going to be impressed by that. If I have to keep rereading bits to try and work out what's going on, then I'm less impressed, and I'm not going to give you necessarily 10 out of 10. But what I'm looking for primarily is it a logically correct program? However you've done it, if it's a logically correct program, you're getting around about 7 out of 10 or better. If it's got mistakes in it, logical mistakes, then it will be lower than that. I'm also not going to bother too much about whether you miss out on semicolons, for example, or misspell variable names, or whatever, because the compiler will fix that. I want you to show you can sort of solve the problem, write the program essentially. Okay? Any other queries? I don't want to spend too on this because I want time to look at another version, but okay, one more.
In the test,
can you write in pencil? I don't mind. When it comes to exams in the summer, if you read the front of the paper, it actually says you must not use pencil. And as of 2 years ago, the invigilators were starting to pull up people who were writing in pencil and freak them out. So after the exam 2 years ago, I had this whole succession of people coming straight out of the exam and emailing me in a panic. I just got told off in the exam because I was writing in pencil, and they stopped me and, have I failed? To which the answer is no, but the invigilators basically follow the rules to the letter, and if they see you writing in pencil, then they'll stop you and they'll write a note on your exam paper saying you were breaking the rules of the exam. So it's better not to. On the other hand, if you did get it past the invigilators, I wouldn't knock marks off for it being in pencil. On the other hand, while you're writing in pencil, you can just cross it out. And the thing is, if you write in pencil and rub something out, I am not going to give you any marks for it because it's not there anymore. If you write something in pen and cross it out, and I happen to notice it's right, and you wrote something that was right and then crossed it out, if it's all in the balance about, do I give him 7, do I give him 6, I might take what was crossed out into account because obviously you've got it in there somewhere, and that's a little better than not having it there at all. So I would prefer you write in pen and just cross things out neatly, which is also what my primary school teacher taught me. So she knew what she was talking about. Okay. Everybody happy with this program so far anyway? Oops. So let's keep going. What I need to do now is write ask1pet. Now it's going to return an integer, but actually if we look at what it's trying to do, it's going to return either 1 or 0 because it's only looking at a single pet, and we want to add 1 to the count if it's an exotic thing and 0 to the count if it's not. So it is returning an integer, but that integer will either be 1 or 0. And at this point, I start to think, actually, I'm being a bit sloppy here. I haven't written comments for any of my methods. So what I ought to have been doing is writing comments for all the methods that say what they do, print a message about the number of exotic pets, and I'd write something there, ask for 50 pets, or ask for a whole series of pets. So here, now it really does matter because you could be confused about this. So this is ask about 1 pet, returning 1 if exotic, 0 if not. And writing that comment also will stop me getting confused about what I'm intending this method to do. By doing that right now, I'm just helping myself not get confused because it's on my mind at the moment, but as I get into the details, I could start thinking it was supposed to be doing something else. Okay, so public static. Now this time it's returning an integer, so it's public static int. And what is it called? Ask1pet. And it's not taking any argument at this point. And open, close curly brackets. And what's this one going to do? Well, the first thing it's got to do, and again, I'm thinking about writing this exactly how I was writing the whole program. What are the main steps that it's got to do? And let's turn them into method calls. So what's the first thing it's got to do? If it's asking about 1 pet, it's actually got to ask the person for the pet, and then it's got to classify the pet. So I can turn that into a method call. So string pet equals string pet equals I need to do some kind of input. And I could turn this into a method call or that's a specific one for asking about pets, but let's just use my general input method that I generally include in my programs. What pet do you have? And I'm not going to worry about scanners at this point and how I'm actually going to input it. I just call the method. It's going to return a string. I will store that in a variable. and just for the sake of the person who asked the question, I've included that in one line this time. And then, having asked for the pet, what I've got to do is classify the pet. And now maybe I could put the if statement here, or I could defer the details to yet another method, depending on how complicated I think it's going to be. And so maybe I'm making this up a bit as I go along now. I could write something that is exotic. Let's try and do it that way. So, if is exotic pet, then what do I want to do? I want to return 1, else return 0. Oops, I've gone off the bottom again. So if it's exotic, the pet, then I want to return 1, otherwise I want to return 0. At this point I'll go back to check the question. I did in the question actually say it should print a count of how many exotics, but it should say whether it is an exotic pet or not. So I don't want to just return necessarily. Maybe what I want to do at this point is actually say print that's exotic. And here, before I return, I want to say print that's not exotic. Or something more complicated, maybe that uses pet and says whatever pet they have. So again, I've deferred some of the detail about working out whether something is exotic or isn't exotic. I could have had one if then, long if then else statement here that says if pet equals cat, then do something, if pet equals dog, do something, if pet equals whatever, do something. Instead, I've done it like that. And let me swap that over to over here. That more or less all fits on. So now I've got to write is exotic. So what is exotic going to do? Well, it returns true if the pet is exotic, e.g. it's a monkey or it's a snake. And so public static, and this time it's returning true or false, so it's a Boolean. Is exotic, and it's passed a string this time that's a pet that you want to check, and I write in my curly brackets, and then I go and think about what this has to do. Well, now I'm going to check the pet. If pet dot equals monkey, then return true, else if pet dot equals snake, then I also want to return true. I could have used an or there. Else, any other case, it's not exotic, so I'm going to return false. And I've missed a few semicolons, I've just noticed, so I'll put those in. So it returns something in each case. It returns either true or false. True if it was monkey, or false otherwise. Okay? And at that point, I've just done that. And what I'm still missing is I haven't written an input method and I haven't written a print method. So if I've still got time, start writing those. Of those, print is most trivial. I'm not probably going to get much in the way of marks for writing print because it's not showing off anything that I haven't already shown. So what it would make sense is to write the input method at this point, because that's showing I can use scanners, and I haven't shown that so far. So actually, I think I've got a slide of this, so rather than writing that out somewhere or other, I'll just throw it because I'm running out of time. Yeah. So there you go. I would then quickly write, oops, if it all fits, something like that, which is my input method. Given a message, calls a scanner and prints it out. And then the print one is actually at the bottom as well. That's really simple, just calling system.out.println. And at that, if nothing else, if all you do is write an input method like that and a print method like that, at least you've shown me you can write methods that are given arguments and return values. So it's worthwhile possibly doing that, even if you can't get much further than anything else. But if the question, and clearly I've said this is about everything we've talked about so far, if it's about loops, then you ought to make sure you put a for loop in it, because if there is no for loop there, you ain't going to get a pass mark, essentially, for a question like this that said, do something 50 times. Clearly, the key, hardest thing about that is asking you about is, can you do things repeatedly? So, any questions about any of what I've done? Yeah. Oh, right, yes, okay, so I got a slide that I thought was doing one thing and it wasn't, so, oh, actually it's a mistake because I've edited it from something else. That should actually say message, because it's being passed an argument, so what I've done is cut and pasted from an earlier method into the slide and then not changed everything I should have done, so well spotted. Yeah, but the idea here is you're being passed the message you want to print, so this works whatever the message is, and you just use what's in the variable message as the thing you print out to ask them to give you the input. Yeah?
Does it matter if you do J-option pane or scanner?
I don't care whether you use J-option pane or scanner, as long as you do it properly and you're consistent about the way you do it and you load the right libraries, that's fine. That's trivial stuff, essentially. It's just about the right libraries and remembering the right methods. I'm not so much interested in what trivia you can remember. I'm interested in whether you've understood the general concepts and can use them, which is why I'm sort of emphasizing, can you use if statements, can you use for loops and so on. The other thing about this, actually, so one last question, yeah? If you forget the syntax, write whatever is the closest syntax you can remember. I'm not going to dock you lots of marks. If what you end up is writing something that looks like Pascal because you've done Pascal at school, you are going to lose quite a lot of marks because you haven't proved you've learned the Java syntax at all. If there's just odd things that you get wrong, then I'm going to be less worried about it. There are some things that are conceptual things that matter. So if you confuse equals equals with dot equals, for example, that shows you're not understanding the conceptual difference between testing equalities of strings with testing integers. So there's some things where it kind of matters, but in general, no. And if you can't remember J-option pane, show input dialog where all the capital letters are, I don't give a toss either, really. I'm not going to really dock much of anything for putting the capital letters of something like that in the wrong place, because I'm not interested in whether you can learn. I'm interested in whether you can program. Yeah. Show the previous slide, i.e. that. If I get time, what I'll do this afternoon is try and write up what I've just written here and actually put the code somewhere online, possibly after I've put it through a compiler to avoid my embarrassment and fixed all the mistakes I've undoubtedly made. I haven't been looking over here too much. Anybody got any queries over here at all? Yes. I didn't put a squiggly line back at the end. My curly brackets. Don't know where you're talking about or what you're talking about, but yes, it's quite plausible. So, are you saying I've just missed a closed curly bracket somewhere? Sorry, I can't hear. The acoustics in here are terrible. So the if and the else. I've missed some curly brackets out somewhere, have I? So I've got open and close, that one should be a bit further down, matches that one, and that one is the one that matches the class. If exotics is not, parentheses, it's not the curly brackets, sorry. So yeah, I missed it. Yeah. So that's the kind of thing I'm not going to be too worried about. I will probably mark it if I notice it or circle it as something wrong, and you might not get 10 out of 10, you might only get 9 out of 10 if everything else was perfect, because I only give full marks for things that are perfect. But anything less than you worry about whether you got 10 rather than 9, something like that isn't going to make any difference at all. Yes? Are you allowed scrap paper? Yes, but all paper gets handed in, so no, in the sense that you mean. You cannot take paper into the exam yourself. You're sitting at a clean desk with only a pen and your brain. The only paper you can write on is paper I provide you with. There is spare space potentially, and for these tests you'll be writing in an answer booklet. So the rough paper is just the answer booklet, and anything that's rough you draw a line through, and all paper has to be handed in at the end of the test. You cannot screw stuff up, take anything home with you. And part of the reason for that is that's the rules in the exams, and you will get into massive trouble if you start walking away with paper out of an exam in the exam hall in the summer. So get into the habit now. So all rough work gets handed in. If you don't want it marked, draw a line through it, but note the point that I said earlier, that personally, if I'm desperate to find marks for you, and you've written something right that's crossed out, I might be sympathetic, but if I can't read it and it's not there, then I can't be sympathetic. Anything else? Okay, we'll have a break. I'll talk a little bit after the break about doing the same program but using records in it, because people were asking a lot about getting set methods. While we have the break, I'm just going to pass out the question thing that I gave out at the beginning. I'll pass out around copies of this. Registers are here. If anybody didn't sign them, you can come and get it. The other ones need to come down now. So these are the answers, the feedback to the sheet that I gave out at the beginning. So don't read the answers until you've had a go at doing it. So you should be getting 2 handouts, essentially. If anybody's got any questions about anything, you can come and ask me now, and I'll hang around after the lecture, like I always do. Can all the spares of both of these handouts come back to the front as well at the end? Don't leave the spares lying around in the lecture theatre, because then anybody who's not here has got a chance of getting them. Anybody up there wants some? Who hasn't signed the register yet? Hands up if you haven't signed the register. So wherever the register is, there's a patch here, it's going round. Make sure it comes back to the front or you'll all be absent. Can you make 2 piles of any spares of the handouts here, and I'll form a queue and ask questions here. Yeah. By writing a bunch of correct things. So if you, most of the past papers, I think I've included feedback which talks about what people do right and wrong and what impresses me, but it isn't necessarily that there's 1 mark for writing exactly this and 1 mark for writing exactly that. It's 1 You know, if there's a 3-mark question that was explained, or you know, a 6-mark question with 2 concepts to explain, you know, it'll have been 3 marks for each of them perhaps. And what I'm looking for in those 3 marks is a good explanation. And what is a good explanation? It's something that is very clear that when I read it, I think a novice would understand that, and it's got concrete examples, and those examples are explained. Okay? So it's not that you're looking for a facts to rote learn that you can then give back to me, because I don't want you to write sentences that you've just learned. I want you to write things in your own words. So it's about how good an explanation of the concept it is. Okay? It works 50 times and then returns. If you look where the return is, it's outside the closed curly bracket. So the only thing that gets done over and over again is the thing inside the curly bracket. So there's only one line there that gets repeated, that's the count gets counted, that's one pass. That's the thing that gets done 50 times. Once you've gone around that 50 times, you'll drop out to return count. So when I is no longer less than or equal to 50, and when I becomes 51, the next line will will be return count. That's the point when you return it. So the return returns 1. It's building up a variable count. You've got some variable count, and each time count gets count plus, it's saying count gets count. Oh, we've got to add 1 to this. Cross out what's there. Change it to the next thing. Put that new number back in count. We just return count. We return whatever value is in there at the end. And there is only one value in there at the end because it's a single variable, a single box. Yeah, and it's replaced by the 2. The next time maybe it's not an exotic peck, so it stays at 2. The next time it maybe stays at 2. And then the next time it's an exotic peck, so it gets overwritten, gets 1 added to it, the 2's thrown away, and it gets 3. So variables are things that only hold one thing at a time. And so the old value is always thrown away when you put a new value in. Okay, who was next? Go on. You couldn't just put int exotics there, because putting it there inside the open and closed parentheses is the thing that says this gets initialized with the value that's passed. It's putting it inside the brackets that does the initialization. So it's a declaration and an initialization if it's inside the parentheses. Yeah. So, yeah, so you're matching that call line up to that. Yes, because then it wouldn't get it initialized if you just put it there. Where would it get the value from? There's nothing special about it. It's just a variable declaration. Yes, you can do variations of that. There are all sorts of ways of writing any of these things. As long as it's the correct way of doing it, that works when you put it through the compiler, that's fine. I'm not going to complain about correct ways of doing it. Not entirely sure what you're saying, but yeah. If when you put it through a compiler it works, then yes, it's acceptable, essentially. If you're doing things that are a little bit beyond what I've talked about, that's fine. That's showing you read around a bit. You've got to be a bit careful not going too far with that, because in particular, if you start doing object-oriented programming, I'm not testing you on object, you're building the object-oriented program. So the small things that you found that I've not talked about, I'm only talking about a very small core, and you've got to demonstrate you can do those things. If you demonstrate you can do those things and you demonstrate you know more than that, that's brilliant. And that's the sort of thing that would make you think, oh, this is 9 or 10 or 7 or 8, given it's a logical program. If you don't have time, then yeah, as long as, the thing is, demonstrate you can do things. If you haven't demonstrated already that you can call methods, then maybe that's a quick way of showing me you know how to declare methods and take arguments and so on. If you run out of time, then it's better to have missed something like that out, having already shown me elsewhere that you can write methods and call them, than miss out for loops. So, there's a balance about look at what can I write next that would show something that I haven't done already if you're running out of time. Yeah. And the closer to a full program you got, the closer you are to getting 10 out of 10. If you don't write the full program, you're not getting 10 out of 10. But, if you show me everything that I'm looking for, I'll be relaxed about small, simple parts missing. It depends on how good you are at writing programs. But divide up the test, it's 75 minutes, there are 25 marks altogether. So sort of. It depends how much time you're giving yourself to read the question. You might decide you want to give more time for the program because that takes a bit more. But that's roughly what you should be doing. Is basically saying, well, it's 10 marks, it's 3 marks per minute, so I should be taking about 30 minutes on it. And then adapt depending on how hard you find other things. Don't care, but I'm not going to mark your design, I'm only marking your program. It doesn't matter, just anywhere on the paper and then put a line through it or note this is the design. But what I'm saying here is this is a way of doing the design as part of the program. It is actually quicker when you're doing time pressure than designing by doing top level programming is a good way of doing it. For this lecture, it's usually there about 2 or 3 o'clock in the middle of the afternoon anyway. Yeah. Are you moving to that side because you... Yes. I don't know anything about the details of that particularly. Sorry. Sorry? So Ascorn Pet gets 4 from Ascorn. It's another method. Methods aren't inside main. Methods are declared inside the class, one after another. Main is a method. Whatever I call these is executive a method. Ascorn Pet is a method. Each of those is a series of things that come one after the other. They're not inside it, no. And you can't declare methods inside methods. You call them inside. So where we say cat plus Ascorn Pet, that's the core. And at the bottom is the declaration, the definition of the method. It always goes back to where it was called from, exactly the line it was called from. So it could be called from different parts, different methods, but it will always return back to whichever it was called from this time. You could write one big method, but then you haven't demonstrated to me that you can write methods, so you won't get full marks. Well, it would be about 6 or 7 maybe, if everything's right about it. But what I'm just trying to demonstrate there is it's a good way of helping you get the thing right, and it's better to get it right and take a little bit longer. No particular number. I'm expecting you to demonstrate that you can, well, no, I'm expecting you to demonstrate you can call methods that take arguments, you can call methods that return value. If you've done that, then I'm generally happy. After that, I am looking for the really high marks, 9 or 10, as to whether it's a really well-written program. Something that's all in one method is not well-written. Okay, I haven't got the register from the balcony back yet. If it doesn't come back, everybody on the balcony wasn't here. I'll be outside at the end, so it can be handed to me out there. Right. I don't want to spend too long on this because I do want to do a little bit about new stuff that you don't need for the midterm test on arrays. But what I haven't done at all in that program is demonstrate anything about records and that I can use records. Let's suppose instead I was going to write a program that did the same sort of thing, but I want to demonstrate the use of records in it. I mean, it's a little bit tenuous in this program to do this, but it kind of could be done. So let's suppose this is actually just the first step of writing a bigger program where it's not just whether a pet is exotic or not. Ultimately, I'm going to want to know lots more about it, like how you look after it, or how long they live, or how cuddly they are, or how dangerous they are, or whatever. So I'm actually going to ultimately want a big record of data about each kind of pet. Lots of information about cats, lots of information about dogs. So let's suppose I was trying to write a sort of small version of the same thing, and I might think actually it's quite useful to have a pet record which keeps all the information about pets. So this is starting from scratch, trying to write the same program again now, but do it using records. And I'm not going to go through the whole of this because I only want to spend about 10 minutes on this. But what I might decide is to create a new type called pet. And what is a pet? Well, for now, a pet is just two things. A pet has a name, so a name would be a string. And it's a Boolean that tells you whether it's exotic or not. Okay? So what I've just done there is created a whole class definition. So I've got the open curly brackets to it, I've got the closed curly brackets to it. I could kind of mentally put a box around that. It's disconnected to the rest of the program. So one of the things some people are getting confused about because they're starting to try and do object-oriented programming is put more things in there. The only thing that is in my class, if I'm trying to define a new type, is variable names. Declarations of them, they're the fields of the class. Everything else goes in the other method. As you switch to object-oriented programming, that will be all about starting to put more detail, more complicated stuff inside this class that's creating the type. But I don't want you to do that because there's all sorts of pitfalls you can fall into, and this is an object-oriented programming method. So this is just a record. I'm creating a very simple type, a type of pet which has two fields. A pet combines a pet name and a Boolean as to whether it's exotic or not. Then I can start on the actual, the equivalent of what I was writing before, which I can't remember what I called the class. I called it pet count. And pet count is going to make use of pet records. So draw in my curly brackets and put in the closed curly bracket. And this is essentially a completely new class. It's a new program that is just like the things we've done before. Okay? So normally I would actually put the pet class actually at the end of the program rather than the beginning. Here I'm going to put it at the beginning just because I want to define it first to show you what I'm doing. But then everything else goes in the same class as main. So public static void main. And so on. And now what I might do is declare lots of things that are pets. So a cat is a pet, so let's declare a variable cat. Let's use uppercase because these are things that aren't going to change. Pet cat equals and I'm going to use a method createPet, which I'll have to write, that is given the name of a pet and whether it's exotic or not, which is just a Boolean. So a cat is not exotic, so it will be false, and pet dog equals createPet dog, also false, and then pet, I'll just do 3 things, pet, snake, createPet, snake, and it is exotic, so we pass true for it. And then what I'm going to do is essentially what I had before. So if I put up what I had before, I'm going to create a count. I'm going to say count gets the value. Oops, I'm off the bottom. Ask about pets. But this time I'm going to pass that information. So these are variables, cat, dog and snake are local variables, so I'm going to pass them as arguments this time so that ask about pets knows about these pet records. And we'll see if I get to it in the second half when I start to use arrays. There's better ways of doing this. And then what I want to do, I then want to print how many are exotic. And I pass the count to that, and that's what it needs to do its job. So what I've got there is again the top level plan of my program, but this time I'm storing all the information about different animals in a set of records, and I'm passing those records as arguments to the methods that are then going to need them. And what are cat, dog and snake? They're variables of type pet. They're things that hold records, that hold the name and whatever value. And having done that, I can then write some variation on ask about pets. What I'll do is I'll just edit the version I've got here, because I'm basically going to do the same thing, but now what we've got here are, it's being passed a bunch of arguments of the order that I put there. There's a pet that's a cat, a pet that's a dog, and a pet that's a snake. And exactly those things are going to need to be passed to ask1pet. So I'll pass cat, dog, and snake to it. But having done that, ask1pet can now be slightly different, because whether the thing is exotic or not is actually stored in the details of the record. So I don't have to sort of do it an if then else in quite the same way as I did before. So I'll switch to a blank piece of paper. Whether that is all going to fit, not really. So there are several ways I might do this, and I'm going to try and do something that's very quick. And I'm probably going to confuse myself. So what am I writing? I'm actually writing ask1pet. So what am I going to do with this? So I'm going to do the input. so I won't write it all out. So pet gets the value, some input value, and then I want to check what's going on. So I've got to check what that pet is. So if pet dot equals cat, then what I need to do is just to extract the details about the pet. So maybe I've got a variable is exotic, gets the value of get exotic from cat, else if pet dot equals dog, then is exotic, gets the value of get exotic from dog, and so on. So presumably I've declared something that's a Boolean is exotic up here. And so now is exotic is telling me whether the thing is exotic or not. And then after all of that if then else statement, I could just say if is exotic, then return 1, else return 0. So that's after the final else of this if then else statement. Oops. Sorry. So after I finish checking whether it's a cat or dog, I've just set a variable is exotic to be that thing, and then I just test. If it's is exotic, I return 1, and if is exotic is false, I return 0, and I've done exactly what I was doing before, returning 0 or 1. Now, all the way through this, so far what I haven't done is actually directly written the methods that access the class itself. So what I'm doing is I'm just writing, I need to get the data about whether a cat is exotic using get exotic, and earlier on up here I'm using a method create pet, and I haven't worried about the details of that. I don't care how at this point that's actually implemented. I can write the rest of the program not worrying, just knowing there is a value there I can get and that I can create them. So at this point probably what I want to do is actually write some of those methods. So this is writing the getter and setter methods, but I'm also going to write something that actually is create pet, is what I called it. So I'm going to write a method public static pet. It returns a pet, create pet, given a string name and a Boolean about whether it's exotic or not. So how do I do that? Well, first of all, I create a new pet, pet p equals new pet, which creates one of those records, and then I start using setter methods. So p is set pet name with the name that I've been given, and I'll need to pass p to it as well, and I update p with set pet exotic p and the exotic value, and ultimately this whole thing is supposed to return a pet. So I've created a pet, I've filled the values, and then I just return the thing that I've created. And so I'm relying on setter methods there, and all of these methods are in the same class as the main method. You know, this thing that I wrote at the beginning stays just like that In its box, it's got nothing else that I've added to it. I've had no methods there whatsoever. Everything that I'm adding is in the same class as the main method. And I'm about running out of time and I want to move on. So what I'd have to do is write all the setter methods and getter methods. I'll just write one of them just as an example. So we need public static pet set pet name. It is given a pet p and a string n, and what does it do? It returns, it returns the pet, but before it does that, the pet dot whatever the field was called pet name, p dot pet name gets the value n that I've just passed to this. So when I pass some name and some pet record that I want updating, I've got the record value and I've got the name value. I update the name value with the new name and then I return a new copy of that pet. And I do the same with the getter methods and so on. So what I've just done there is write a version of this program that's a completely different way of doing it, where I'm using records to store all the data about the pets, which for a small program like this is a lot more work, but as I was getting to bigger and bigger programs with lots of pets, it makes it less work, and when we go on to doing arrays, we then got a way of combining this with what I'm going to talk about next that makes it all easier. Okay, sorry, you've got a question. So, why is it quicker? It's not quicker, it's better coding. And why is it better coding to use getter and setter methods rather than just use the dot notation to go straight there? So at this point where I said, where are we? Oh, we're over there. At this point where I said set pet name p dot name, I could have just written the dot notation there instead of calling a method to do it. Why do you call methods to do it? Because at a later point I might want to change the way I've implemented that record, and if I did that, I would have to do it the way you're suggesting. I'd have to go through the whole program looking for everywhere where I've used the dot notation, potentially to change it to something else. And that's error prone. It's easy to miss one of those places, and you might end up with a program that does something, has some really obscure bug. If you do it this way, what you know is if you change the implementation, all you've got to do is change the getter and setter methods, and everything will work. So here, I haven't even used it for create pet. I've again used the getter and setter methods. So if I change the implementation of the record, and I change the getter and setter methods, my create pet methods should still work. And that's the point. When you go to big programs, you want to localize what you have to change. If you make changes, you don't want that mean you've got to change 1,000 lines of code because you probably miss some of it, or you get confused and change it in one way in one place and in a different way in a different place. So it's not about being quicker, it's about writing better code as you get to larger and larger programs. And in about 2 weeks' time, when we talk about abstract data types, we'll see a more extreme example of that, how it's really, really important. And you're already using an example of that. You have no idea how you manipulate strings, for example. You don't even know how they're represented. Are they just an array of characters, or are they some other sequence of characters in some other way that they're stored? Are the individual characters stored in different places in memory all over the place with pointers from one to the next? You don't know, and you don't need to know, because you're accessing it through the equivalent of getter and setter methods, essentially. You know how about plus and that operation, and plus works, and that's all you care about. So it's about caring about the operations, not the underlying detail of how it's done. Any other questions? One last one, and then I want to talk about arrays, at least a little bit. Yeah. So all the stuff in the main... this stuff. So that's the same plan as we had before. So you're asking about, does this need to be here or could it be somewhere else? I've lost where you are actually, I can't wave to me. Oh, there you are. Hello. Sorry. So this is a good place for it to be because it's setting up all the data right at the beginning. It's saying this is the data we've got, and then we're passing it from there just to the methods that need it. You could define it perhaps just inside, you know, this method. It could be defined in there because that's the first point it's needed, but then it's sort of buried a little bit in the depths of the program. So it may depend on the program, but for now, in the kind of programs you're writing, it would be better to put this kind of stuff here. Because the other thing is you might find later that actually you need this information somewhere else. So perhaps what you want to actually do is this method wants to print something about which ones were exotic. And so then you suddenly find, oh, it needs cat, dog and snake, those record details as well. And if you've defined them somewhere else, it's not available to be easily passed on. So you define it at the top level, and then anybody that needs it, you can pass it as arguments to those methods. Yeah? Okay. So, 2 points about doing that. First is to show there is no single right answer to any program I might ask you to write. And even when I write them, I will write them different each time I write the program. What I want is you to write something that is an easy to understand, easy to maintain program that basically demonstrates you can do whatever you can do. And the other point is just this top-down programming approach where you're starting at the top level and just breaking it down and planning as you go, not worrying about the detail of the methods until you get to writing that method. Just decide what it needs to do at the time when you use it, and you know, this calling pattern is the common pattern you're going to do. That you'll call a method, it will return one or more, well, it will return a value, other methods may retain other values. You collect those in local variables to main or wherever's calling it, and then you pass them to the other methods that need them. So create things in main or by methods called by main, and then pass them back out to anything that needs them. And that's the common way of kind of structuring programs that makes it easy to do this stuff. And a lot of the questions on the forum where people have been getting confused is sort of because they're not following this kind of style of top-down programming and defining things at the top level and then passing them out, getting them back from a method and then passing them out to a method. So if you haven't tried writing a program like that before tomorrow, then maybe have a go at writing your own version of this example or one of the other past papers from the midterm tests of the past. So have a go at writing things like that. That's essentially what you're going to have to do as one part of the exit test, of the midterm test. The other things you've got to do is be able to dry run programs and explain concepts using concrete examples. Okay, so new topic. So this isn't anything I'm going to explicitly test you on in the test tomorrow. So this is new. We'll be testing you on the exit test. There are ways you could use this potentially, you know, in the midterm test, and if you know how to do it, there's no reason why you shouldn't. So you can go further, but you can get full marks without doing this in the programs that you have to write. And what we're talking about now is how do you write programs that process bulk data How do you write programs that process bulk data? So let's suppose I really do want to do what I was saying for that program, I want to basically get details of every pet that anybody in this room's got. So I want you to basically queue up and tell me about your pet, everything, you know, its name, what type of pet it is, when it was born, how old it is, or whatever. So what I want is lots of information about pets. Records are good at finding out lots of different pieces of information about the same thing, but it doesn't really help you if you want to find out about 450 different things of that kind. Or if I wanted to find out everything about each of you, you know, I wanted to record all your names, or all your ages, or all your coursework marks, or whatever. The only way I've got of doing that so far is essentially having different variables and storing each value in a different variable. And that's sort of what's going on with this PET program, and partly why I was doing it like this here. If we go back to what's happened here is there are lots of different sorts of pet, and what I'm having to do is define a new variable for every single pet that I want to be able to deal with. And it would be a lot easier if I could somehow keep track of all of that thing in one variable instead of lots of variables. So instead of, you know, I've got 430 people here, instead of having one variable for each of you, or each person, what I really want is to just have one big variable that can keep all of that information in. Keep information for the first person and the second person and the third person. And what I want is to do something very similar, what I'm talking about with records. So essentially what I'm after is, I want a way, but it's a slightly different way now, of taking the individual variables. Each of those variables can hold information about one student, about one of you or one pet, and be able to stick them together and talk about them as though they're one variable. I could give the whole thing one name, but actually, when you look inside, it's got 430 compartments, and in each compartment I find the details of one of you. And that would get around what I'm doing here. If I was doing that with pets, maybe I can have something that's got 50... No, let's not use 50 because that confuses. Let's suppose I've got 20 different sorts of pets I know about, and I don't want 20 variables, one for each pet. I just want one variable that has all the pet details in it. And in each of those would be a record. You know, the first one has the details of cats, the second one has the details of dogs, next one has the details of snakes, the next one has the details of monkeys. So each compartment is the equivalent of a variable itself. But the difference between records and arrays are records are storing lots of information about one thing, and so each of these compartments might be a different shape or size. We might have an integer, and then a string, and then an integer, whereas what we want now is everything to be the same. So if I'm storing all of your names, for example, in an array, what I might want is lots of identically sized compartments, each one that can hold a single string. They're all the same type. So with a record, the different compartments are different types. With an array, what we're talking about now is gluing compartments together to make a single variable where everything is the same type. And that's the fundamental difference between the two. But it means arrays can be flexible in sort of ways that arrays aren't. And in particular, arrays go really nicely with for loops. So for loops are a way of doing something over and over again some number of times where you know that number in advance. So you want to do it 400 times. That's what a for loop's for. So an array is the equivalent for data. It's not that I want to do something 400 times, it's that I've got 400 pieces of data. And so what I want is to create 400 compartments to put 400 pieces of data in. And if I do that, I can use a for loop to scan down that array, looking at each in turn. So that's what we're aiming for with arrays. And so the idea is, what we're going to have is something like this. So this is say, an array of characters. I want to store, in this case, 7 different characters. So my little picture at the bottom is the boxes stuck together. It's one variable, but it's got lots of characters in it. And each place is storing a different character. Maybe it's a code program that I'm writing, and what I'm storing is some ciphertext, for example. Okay? So what we need, if we're going to do this, is we need some way of referring to the whole thing, i.e. give the whole thing a variable name, but we also need ways of referring to each compartment. With records, we refer to each compartment using its field name. So we write that class definition, and the whole point of the class definition is to give us the field names that refer to the different compartments. With arrays, because everything's the same, each compartment has the same type and holds the same type of thing. What we use to refer to the compartments are numbers. So the numbers along the bottom are not values, they're part of how you refer to a particular compartment. So if I want whatever's in this compartment, I'm talking about compartment 0. If I'm talking about what's in this compartment, I'm talking about compartment 4. So essentially what we're doing is we're going to create variable names now that combine the name of the whole box, the name of that whole thing, with a number that tells you the position of the thing you're interested in. So am I interested in student 0, the very first student, or am I interested in student 231, somebody a long way down the queue, and I use their number to refer to the position. And this is essentially what's going on with your student numbers on your ID cards, and why we're so obsessed with your number, not just your name. Essentially, your number is giving us the index into a data structure like an array. It's telling us where to find the data about you. So, how does this work? I might switch to slides at this point. So, what are we going to want? We're wanting to create values and corresponding variables that are compound values, where the values stick things together. So, let's suppose you want to create something that's an integer array, i.e. we want to store lots of integers. Maybe it's all your ages. So, what am I going to need? I'm going to need the name of the variable, I need to say that it's one of these special things, and you then need the compartments. So there's sort of 2 parts to doing this. So we're going to give the whole thing a name A, and the compartments are going to count from 0. So how do I declare something like that? Essentially, it's going to hold integers, so its type is going to be related to integers, but it's not just int, it's integer array. And so you use square brackets after the type to say you're not wanting one cell, you're wanting lots of cells. And that so far doesn't tell you how many cells you want. And then you give it the name, whatever you're going to call it, just like anything. So this is no different to me writing something like int A. I've got a type and I've got a variable name. I've got a type integer array and I've got a variable name. And you could stop at that point, and what you've created is something called A that can hold lots of integers, but you haven't actually told it how many integers to store. There's another step you need here, which is to create the storage space and say how big an array it is. So arrays are fixed at the time when you declare them, essentially. And so what you then do is use new. So similar to what we've been doing in other situations, we're creating a new one of these things. So it's a new integer array, and you give the type again, but this time, in square brackets, you give the size. So this one that I've created here has got 4 entries. So I put the number of compartments there. So this is type, name, create something of size 4. So that is how I would declare an array like that, called A, with compartments numbered from 0 to 3, so that it has 4 compartments. Okay? And all we're doing here is exactly the kind of thing we were doing before. I'm just declaring a variable, but I'm declaring a variable that's big enough. What I'm saying there, precisely, is I'm declaring a variable that actually has, well, I don't have enough hands for this, that has 4 compartments. I'm declaring a variable like that in this case, because I've said 4 is going to have 4 compartments to the box that I create. Those positions are going to be called position 0, position 1, position 2, and position 3. And that's the first thing people get confused about. It's got 4 compartments, but the last one is position 3. And this goes back to somebody asking me, do you count from 1 or 0? For arrays, you always count from 0. The first entry of an array is always position 0, which means the last entry of an array is 1 less than its size. So if I declare an array of size 100, so it has 100 compartments, the first position is still 0. What is the number of the last position of that array? Blah, blah, blah. Count of 3. The number of the last position is 1, 2, 3, 99. Did you get that right? No. If it's got 100 positions, the last position is always 1 less than its size. Okay? So you start at 0, count up to 99. So if you've got 5 things instead of 4, they count 0, 1, 2, 3, and 4 as their positions. And there's a new thing you can get confused about now. We've got more numbers in the fray. We're now using those numbers 0, 1, 2, 3, and 4 to talk about the position. Now, what we've got here, 0, 1, 2, and 3, those are not anything that's stored. They are part of the name of those compartments. So even though this is storing integers, the values in them that we've initialized them to, the values that are stored are integers. They're different to the values here. They're not the things that are stored. Those are the way you name them. So if I wanted to print the thing that's in that position, I would say system.out.print line. And I want to go to variable A and print out what's in position 0. So I put the square brackets again. A0 is just the name of the variable that is go to A and go to position 0, and I print out what's ever in position 0. I print out what's there. 0 is its position. That's different to the value that's stored in it. In this case, what's stored in that position is 10. So when I look in it, I find a 10 there. Position 0 holds the value 10. So what would print if I do system.print line A0? I'd print out 10. Essentially, you can think about that as just being the variable name. The variable name is A0. So that compartment is called A0, that one's called A1, that's called A2, and that's called A3. Yes, question? Shh. So I didn't hear the first part of that, but the second part is true. Yes, when you want to refer to individual compartments, you count them from 0. That is position 0. What was the first part? Yeah? Yeah, so the number I put there is the size. That's how many compartments, not how you're numbering them. If you put 4 there, you're numbering from 0 to 3. If I put 99 there, I'm numbering from 0 to 98. If I put 1,000 there, I'm numbering 0 to 999. Yeah? But I'm always counting from 0. Okay? So, this kind of seems weird, but it's not actually so weird, this idea of counting from 0. Has anybody been in the lift in the ITL? Okay, it's a very weird lift. If you haven't been in there, go and have a look in there at some point in the near future. So, why do we count from 0? Is that something weird? No, it isn't. In this country, at least, we count in 0 as a natural course of things. So, what is the ground floor of a skyscraper? What number is that floor? Well, it's the ground floor. That G just means 0. Because what if you go up one floor to the first floor of a skyscraper, what floor are you on? You're on floor 1, the first floor. If you go up to the next floor, you're on floor 2. Skyscrapers count from 0. They go ground 1, 2, 3, 4. Okay? So G just looks like 0. Vandals have been scratching out the rest of the 0 or something. But we naturally do that, and you don't think twice about it. It's just natural that, of course, the first floor is the one up. It's not the first thing you get to. That's what we're doing here. Think about an array of being that way up. That's the ground floor at 0, 1, 2, 3. And if you look in the ITL, unlike any other building, you'll find that it's not the ground floor you're on. You're actually on floor 0, according to that lift. I suspect because a professor of computer science actually wrote the spec of what that lift was supposed to do, and so he told them, I suspect, to make sure the lifts were numbered from 0. Okay? So it's not weird, unless you're American. Is anybody here American? Anybody here from the, You're thinking, what on earth is he talking about at this point? Because in America, you don't do that, do you? You count from 1. You're just weird. We were here first. So we must be right. Anyway, so this is one of the things you have to worry about with writing programs. There are cross-cultural differences about things. You go to a different country and they do it completely differently. But if you're in this country and you came to study in this country, we count from 0. From now on, with arrays, get into the habit of counting from 0. And you will, every single person in this room at some point in their life will get this wrong. And you'll count an array, and you'll put 4 there, and you'll count from 0 up to 4. You've got to get that right. It's very confusing, it's a very easy mistake to make, and it's the most common mistake people make when using arrays. So, I just want to show the time that I've got sort of one little thing about what this allows you to do, if I can find something to write this on. So, here I've got numbers 10, 11, 12 and 13 in that array. So there are 2 ways I could go about putting those values in. So we've said that the variables are called things like A0, so I could say A0 gets the value 10. I put a 10 into the 0th cell. And then I could say A1 gets the value 11. And A2 gets the value 12. And A3 gets the value 13. And I'm already bored about doing that. If I had 1,000 entries to write, I'm going to have to write 1,000 assignments. And the whole point of doing this and having a single array is actually so you can do this with a for loop instead of having to write that out over and over again. So instead of doing that, what we can do instead is essentially write a for loop that does the same thing. For int I gets the value 0 this time because we're counting positions in the array. I less than or equal to 3, which is 1 less than the size of the array, or alternatively we could actually write I less than 4 there and use less than to allow us to write there the size of the array. Either of those would work. I plus plus. And what I can now do is say A in position I, because I is going to change. I will be 0 the first time around this loop, and this will mean A0. Second time around the loop it will be 1, so I'll be saying A1 gets the value of something, and so on. So I can say AI gets some x, and I could just add 1 to x each time. X gets x plus 1, and if I set x to be 10 at the beginning, what I'll have done is say ai gets x is 10, and we add 1 to 10, it's 11, and we add 1 to y, so we're now going to position 1, and so now we'll put 11 into there, and then we add 1 to x. So essentially we could do exactly that, but in a for loop. And of course, I haven't actually saved any lines at all doing this because I had 4 lines there and 4 lines here. But let's suppose actually what I've got is an array that was 1,000 lines long. So my first declaration of the array now was integer array A is a new integer array of size 1,000. And what I did there is I go up to 999, from 0 to 999. And the same lines of code will fill an array that's got 1,000 entries. So the point about this is that little for loop can use the counter I. You know, I is just me keeping track of where I am on my fingers. I'm in position 0. I could put a value in there. I add 1 to I. I'm now in position 1. So I'm now putting something into there. I put I to be position 2, and I put something there. I put I position 3, and I put something there. So essentially, I'm able to combine for loops with arrays, and I can store things in an array using a for loop, and I can print things out using a for loop in a similar kind of way. So let's suppose I want to print the whole of this array out. I can do the same kind of thing. I can just write a for loop for int I gets the value 0, I less than or equal to 999, whatever the size is, I plus plus. System dot out dot print line A at position I, where I changes each time, so we'll be printing a different thing each time around the loop, and I've printed the whole of the thing out. So that works if the array is 999 lines long, entries long, 1,000 entries long, 1,000,000 entries long. All I've got to do is get that number right, and that tells me how far down the array I go. And that's the point about arrays, that it allows you to process bulk data essentially using for loops. We'll see other things you can do with them later. Okay, I'm going to stop now. Make sure the last balcony register comes back to me. So somebody bring it down and hand it to me either here or outside. If you didn't get the handouts, there are 2 here. Can you bring any spare handouts down and just drop them on the piles as you go past? And I'll stay outside for as long as people want to ask me questions. And get there as early as you can for the test tomorrow to your lab. We'll start as soon as we've got everybody set down and ready to go. It won't be bang at the start, but it'll be pretty close to the start. But if there's anything you're not sure about, you want me to explain before the test tomorrow, just come and see me afterwards. Or post a message on the forum. I'll try and answer stuff this evening.